Go.
Okay, so we're going to do a sample problem of just a common problem that can demonstrate the importance of force diagrams in solving equations. We have this random guy who's going to be pulling a box along the ground like that. Okay, so then we just have this box, and then we want to know, let's say we just want to know some sort of information about it. I can't think of anything. We probably will have more specific example in the AP problem. But if we just examine the box right now, we can look at it as in a force diagram. That's not exactly what
Say that last part again.
Okay.
And that's how you.
So first, you always have to think, are there any field forces on this box? And yes, there is the force of gravity from the center of mass going downwards. Direction is really important because it determines whether the force is in the x component, the y component, or if it needs to be split and such. So, sign convention. Oh yes, also whether or not it's up or down, so you can add or subtract it from other forces. For this, we can determine which we want to be up and which we want to be down, and generally, it doesn't matter as long as it's consistent throughout the problem. So you should set it at the beginning of the problem. In this problem, I'm just going to set up as positive and to the right as positive, because he's pulling up and to the right. No particular reason, it would work the other way, just it would be negative. So now we have to think about contact forces after the field forces. And what is the box in contact with? Well, it's in contact with the rope that the guy is pulling with. And that comes from the tip of the box and goes in that direction. And that is the force of tension from the rope. This is important on the force diagram because you can see that the force comes at an angle theta away from the x, up from the x-axis. So when we consider the actual value of the force of tension, we have to consider the x component as well as the y component of the force. Not just like in gravity, which is just the y component. An additional force that counteracts gravity that I forgot about earlier, that is generally always present if it's in contact with a surface. There's the force of gravity, there's the force of natural force off of the surface, and since the surface is not frictionless and there's a natural force, there's also a force of friction contradicting the direction of motion. So force, and it's kinetic friction because it is moving. Too late. Okay, we're done.